This is SpaceTime, Series 28, Episode 30, for broadcast on the 10th of March 2025. Coming up on SpaceTime, scientists finally match Earth's ice age cycles with orbital shifts, another Starship crash and burn, and ghosts on the Moon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have finally discovered a predictable pattern for the timing between Earth's glacial and interglacial periods with changes in the planet's orbit around the Sun. Beginning around 2.5 million years ago, planet Earth entered an era marked by successive ice ages and interglacial periods, and emerging from the last glaciation around 11,700 years ago. Now, a report in the journal Science says that if this pattern holds true, the onset of the next ice age could be expected in around 10,000 years from now. The findings are based on a new interpretation of small changes in Earth's orbit around the Sun, which lead to massive shifts in the planet's climate over periods of thousands of years. The study tracked the natural cycles of the Earth's climate over a period of 1 million years, and it offers new insights into Earth's dynamic climatic system, representing a step change in understanding the planet's glacial cycles. The authors examined a 1,000,000-year record of climate change, documenting changes in the size of land-based ice sheets across the Northern Hemisphere, together with temperatures in the deep ocean. They were able to then match these changes with small cyclical variations in the shape of Earth's orbit around the Sun, its wobbles, and the angle on which the axis is tilted. See, none of these orbital manifestations are fixed, but they do follow a cyclic pattern. The study's lead author, Stephen Barker from Cardiff University, says there's a predictable pattern over the past 1,000,000 years for the timing of when Earth's climate changes between glacial ice ages and milder warm periods like today, which are known as interglacials. He says one type of change in Earth's orbit was responsible for the end of ice ages, while another is associated with their return. Barker says what's amazing is that no one's noticed such a clear imprint of the different orbital parameters on the climate records before. Predictions of a link between Earth's orbit around the Sun and fluctuations between glacial and interglacial periods have been around for well over a century, but weren't confirmed by real-world data until the mid-1970s. And since then, scientists have struggled to identify precisely which orbital parameters are most important for the beginning and ending of glacial cycles. That's because of the difficulty in dating climatic changes so far back in time. Now, the authors were able to overcome this problem by looking at the shape of the climate record through time. This allowed them to identify how different parameters fit together in order to produce the climate changes observed. They found that each glaciation for the past 900,000 years follows a predictable pattern. Now, this natural pattern, in the absence of human greenhouse gas emissions, suggests that we should currently be in the middle of a stable interglacial, and that the next ice age would begin many millennia into the future, roughly 10,000 years from now. Barton says the pattern's so reproducible that you could make an accurate prediction of when each interglacial period for the past 1,000,000 years or so would occur and how long it would last. And this is important because it confirms the natural climate change cycles observed on Earth over tens of thousands of years are largely predictable and not simply random or chaotic. These findings represent a massive contribution towards a unified theory of glacial cycles. Because Earth is now in an interglacial period, called the Holocene, scientists are also able to provide an initial prediction of when the current climate will return to a glacial state. However, the thing is, this next transition is very unlikely to happen in real life. That's because human emissions of carbon dioxide and other greenhouse gases into the atmosphere has already diverted the climate from its natural course, resulting in longer-term impacts into the future. This is SpaceTime. Still to come, another Starship crash and burn, and ghosts on the Moon. A new lander reaches the lunar surface, but other lunar missions currently underway appear to be in trouble. All that and more still to come on SpaceTime. SpaceX have experienced another Starship failure, with the test flight exploding in the skies over the Caribbean just seconds before achieving orbit insertion. Fiery debris from the spacecraft's destruction was seen raining down over a wide area from the Dominican Republic to the Bahamas, forcing the closure of several airports and the diversion of numerous local flights. No one was injured in the spectacular breakup, and several accident investigations are now underway. The launch was the 8th test flight for the world's biggest and most powerful rocket. The mission used Starship 34 mounted on Super Heavy Booster 15. The flight also included 4 SpaceX Starlink satellite simulators, which were to be deployed once in orbit. The test flight from SpaceX's Starbase at Boca Chica in Texas began smoothly with a 123-metre-tall gleaming stainless steel rocket blasting off the launch pad just as planned.
And clock is rolling. Our flight director, Joe Schleicher, today is go for launch. Let's listen in as he takes us through the final seconds of the count.
T-minus 8, 7, 6, 5, 4, 3, 2, 1.
All right, 40 seconds into the flight, we are seeing 33 out of 33 Raptor engines ignited. Boosters pushing us downrange over the Gulf.
Max Q.
All right, so we're through Max Q. That's the heaviest stresses it's kind of seeing on the way up.
Pitching downrange away from the launch tower.
The ascent to orbit appeared to proceed nominally, with a textbook separation of the Starship Super Heavy booster from the upper stage.
Next thing coming up is hot staging. So we're going to look for 6 engines to ignite on ship while we're still attached to the top of the booster. We'll see all but those 3 center engines shut down on booster.
We're hearing the initial call that we are go for booster catch back here at the launch tower. Coming up now on hot staging, the ship's engines will ignite while still attached to the Super Heavy booster, and also while Super Heavy booster will still be under power itself. The clamps holding the 2 stages together are going to release. Starship second stage engines will
Booster engine
ignite.
cutoff. Ship engine startup. Stage separation.
Boost back burn also went smoothly, placing the reusable booster on its correct re-entry trajectory.
Boost back burn startup.
There we go. Ship engines, all 6 Raptors ignited. We're doing that boost back burn. Looks like we got 11 of the 13 that we command for that, so that's going to start sending the booster back. We are still go for booster return, even with 2 Raptors out during that boost back. We can do a full duration one. But
chamber pushes nominal.
looks like we got a ship, 6 engines heading into space, and then we got a booster hopefully on our way back to Starbase. How's everything going in Hawthorne, Chris?
Everything is looking good. The crowd eagerly followed that ascent and now watching the booster coming back. We're down to 3 engines on the boost back burn. Ship with 6 engines lit, continuing its ascent to orbit, already over 100 kilometers in altitude. The booster 87 kilometers in altitude and continuing its trek right now back to the landing site and catch site. There's a
shutdown.
And we just heard a good call out for boost back shutdown. The next thing we should see is the separation of the hot stage from the Super Heavy booster. We jettisoned that because we do not need it for the landing, but on future iterations of the Super Heavy, that hot stage ring will be incorporated into the booster and we will get it back. The booster doing its liquid oxygen dump there, which is exactly what we would expect for it to do as the booster gets itself configured for the landing here. Now, meanwhile, Starship will continue to coast after it reaches orbit for about 40 minutes or so up to an altitude of 214 kilometers, but it's still got a ways to go there, currently accelerating past 7,500 kilometers per hour there in velocity. Absolutely gorgeous.
Starship is on a nominal trajectory.
And there we hear nominal trajectories all around. And Dan and Kate, we're at 5 minutes, 15 seconds here into the flight. Everything looking good for the Super Heavy and for Starship today. What's it like there at Starbase as we get ready to catch?
We are standing by for return of booster back to the launch tower. We have heard that we are go for the catch of the booster.
So coming up in just about 30 seconds, we're going to look for the landing burn. We're going to command those 13 inner and middle ring engines to turn on. 13 initially, they bleed off all of that velocity as we're slowing down from supersonic speeds, eventually moding down to only 3 engines for that precision flight into the tower.
Right now, booster using its 4 hypersonic grid fins to help guide itself through this atmospheric entry back for its precision landing at the launch site. Once again, we're going to ignite first the center 13 engines We should see that coming up here momentarily.
Engines in startup.
This is going to come down to 3 engines as the booster slows down for its landing. And we just heard the sonic boom.
It eventually achieved a spectacular launch pad landing, with the mechanical chopsticks grabbing the 71-metre main stage just on main engine cutoff. It was the 3rd time SpaceX had achieved this stunning technique.
Wow, that will never get old.
All right. We saw 12 out of 13 light for that landing burn. Booster still able to make its way with that final precision burn on the 3 engines in for the tower catch. So booster caught. Meanwhile, keeping an eye on ship. Still got 6 Raptors burning. Those are going to continue for about another minute until we'll get to the Starship engine cutoff.
Meanwhile, the 52-metre tall Starship upper stage continued on its ascent to orbit, heading southeast towards the Atlantic Ocean, with all engines burning as expected. The flight should have continued more than halfway around the planet on a suborbital trajectory before re-entering the atmosphere over the Indian Ocean and undertaking a controlled splashdown in the waters off the Western Australian coast roughly 50 minutes after launch. However, just 30 seconds before orbit insertion, Starship suddenly began losing attitude control, with one of its vacuum engines and then all 3 sea-level Raptors shutting down in quick succession and the vehicle tumbling wildly out of control. As it began spinning, propellant levels were seen jumping all over the place, resulting in voids in the propellant feed. That wound up killing the 2 remaining engines. That was quickly followed by the loss of signal and communications dropout as the spacecraft experienced what SpaceX euphemistically described as a rapid unscheduled disassembly. In other words, the spacecraft blew apart.
And we just saw some engines go out. It looks like we are losing attitude control of the ship.
Ship FTS is saved.
So we're still getting video down from the ship. We've lost several engines and we've lost attitude control of the vehicle. So we'll continue to stick with it.
Unfortunately, it seems as though we lost the attitude control of the ship. We are standing by as we listen in with the teams on the nets to understand what information we're able to provide you. We will provide that as soon as we are able.
And at this point, we've essentially lost contact with the ship. We're no longer receiving telemetry at this moment. We saw several of the engines start to cut out. Once you lose enough of those center engines, you're going to lose attitude control. And so we did see the ship start to go into a spin. And at this point, we have lost contact with the ship. So pretty obvious we're not going to continue the rest of the mission today.
This 8th test flight followed a similar storyline to the previous test in January, with the booster also landing back on the pad and the Starship orbital section also exploding in mid-air. That failure back on test flight 7 was caused by harmonic responses several times stronger in flight than what had been seen during testing, resulting in additional stress put on propellant lines. That stress led to propellant leaks, and those fuel leaks eventually ignited in a section of the Starship known as the attic, a void between the bottom of the liquid oxygen tank and the rear heat shield. SpaceX made several changes prior to Test Flight 8 in order to prevent similar ignition points, including adding more ventilation in the unpressurized attic area. Test Flight 8 was designed to stress test specific vulnerable areas of the upper stage by removing some heat shield tiles. SpaceX says these multiple metallic tile options, including active cooling, would test alternative materials for protecting Starship during its re-entry. New non-structural versions of Starship's catch fittings were also installed on the sides of the vehicle in order to test their thermal performance, along with a section of the tile iron receiving a smoothed and tapered edge in order to address hotspots observed during the re-entry on Starship's 6th test flight. The mission also tested new radar sensors on the Starship launch tower, designed to increase accuracy when measuring the distance between the chopsticks and a returning booster. This second Starship failure in a row is a serious setback for SpaceX's development of the vehicle, which is essential to NASA's Artemis lunar exploration program. See, Artemis will use the lunar lander version of Starship, the HLS, to transport humans from the Orion spacecraft to the lunar surface on the first 2 manned landings in the program, which will be the Artemis 3 and 4 missions. Artemis 3 is slated for launch in 2027. After that, the HLS will be used for crew and cargo transfer between the Lunar Gateway space station, which is now under construction, and the Moon's surface. This is SpaceTime. Still to come, there's a new lander on the lunar surface, but 2 other moon missions are in serious trouble. And later in the science report, a new study has proven once and for all that vaping will not help you quit smoking. All that and more still to come on SpaceTime. There's a new lander on the lunar surface, but 2 other moon missions are in serious trouble. Firefly Aerospace's Blue Ghost is undertaking the first ever successful commercial landing on the moon. Launched on January the 15th aboard a Falcon 9 rocket from the Kennedy Space Center in Florida, together with JAXA's Resilience Hakuta 2 mission as part of NASA's Commercial Lunar Payload Services initiative, Blue Ghost went into orbit around the moon on February the 13th. It then descended towards the lunar surface on March the 2nd, aiming for the slopes of Mare Crisium, an ancient volcanic dome in an impact basin on the moon's near side northeastern edge. A half-hour after landing, Blue Ghost started to send back its first images of the lunar surface, including a selfie and a shot which included the blue orb of planet Earth glimmering in the sheer blackness of space. There was also the first ever video shot by the spacecraft as it descended to the lunar surface. The gold-coloured 4-legged lander is a basic box-shaped structural framework with 2 decks. They contain 10 different scientific payloads totaling 155 kilograms. This mission is investigating heat flow from the lunar surface using a drill, which will bore down 3 meters into the lunar regolith, measuring temperature and gas release as it descends. The mission will also look back at the Earth from the lunar surface, taking X-ray images of the Earth's magnetosphere using its heliospheric X-ray imager or LEXI telescope. LEXI's data will enable a better understanding of how Earth's magnetic field protects our planet from the sun's solar wind and flares. And it doesn't end there. Blue Ghost's technology tests include regolith sampling, regolith adherence, global navigation system abilities, monitoring both the American GPS and European Galileo systems. There's a computer radiation tolerant test, and there's Planet Vac, which will capture lunar dust after creating a small whirlwind of gas.
My name is Farris Berry, and I'm the Director of Spacecraft Mission Management here at Firefly Aerospace, and I'm on the payload console for Blue Ghost Mission 1.
My name is Alan Butler. I am the Blue Ghost AI&T lead, and for the mission, I'm on the systems console.
We have 10 payloads on this mission. 9 of them are active instruments. They have power and data interfaces. We've been able to check all of those payloads out. We've powered them on. We've gotten them data back.
The last 2 weeks of the mission is where we're there to make sure that the payloads are getting everything that they want to get out of this mission. So all the science data we can get them, we're going to get them. So for the systems chair, that means making sure that the lander is staying healthy enough from a power and thermal perspective to make sure we can stay powered on as long as we possibly can, and that our data budgets are healthy and we can get as much data down as we can. We'll be helping prioritize different conflicting operations and providing insight when anomalies occur, but that's our overall goal.
We are operating for 1 lunar day on the surface. That's about 14 days. We are operating from sunrise to sunset. There's a lot of things that we have to monitor throughout the 2 weeks. As we get to lunar noon, a lot of things get really hot, so there are restrictions there on what can operate and what can't operate. So there's a lot that we're trying to fit in, but there's still some restrictions that we have to work around. And then, of course, on the other end, we plan to operate for several hours into the night. We'll take some really interesting images of the sunset, and then really operate as long as we can into the night. And then eventually things get really cold, so there's restrictions there as well. So we kind of have to work out our mission operations plan to maximize the amount of science we can bring down for that 2 weeks.
It's been an amazing journey to be on console. My team and myself, we had our hands on every piece of the hardware from the assembly. We were there every step of the way for the testing, both here in California and in Florida. We watched it launch from the beach, and so to get to wrap it all up by being on console and see how well it's doing, through all the challenges and everything, it's just been really rewarding for me personally and gives me a great sense of pride for what I've been able to contribute and also what my team has done.
For me, it feels really exciting to get there. This is what we've been working for. We've had a lot of those payload operations, during transit, but the majority of those payload operations are going to be on the surface. So it's really going to be the payload's mission at that point. We're going to make sure that we are able to support all of these payload mission objectives, and that's what I've been working for over the past 4 years. I am just looking forward to that, looking forward to just getting the work done and celebrating for a little bit, but just kind of getting heads down, making sure that we're not wasting any time, that we're using those 2 weeks and using them to the maximum that we can to get all of the data down that we can during that time.
Blue Ghost's arrival was followed on March the 6th by Intuitive Machines' IM2 mission aboard the Athena lunar lander. Launched on February 26th, also aboard a Falcon 9 from Kennedy, Athena was carrying a drill capable of digging a metre below the surface in search of ice, as well as a unique hopping drone called Grace, which is designed to explore the moon's underground passages carved by ancient lava flows, and 3 lunar rovers, one of which is designed to link with the lander and hopper using a Nokia-based cellular phone network, the first of its kind demonstration on the moon. However, at time of our recording, the news for Athena isn't good. The vehicle appears to have landed on its side, following problems with the engine not turning off during the descent burn. Intuitive Machines says its lander appears to be on its side just outside the designated landing zone on the Mons Mutan Plateau, 160 kilometres from the lunar South Pole. Now, if all this sounds familiar, it's because the IM2 mission appears to have echoed the failure of Intuitive Machines' first lunar landing attempt with the IM1 mission last year. Back then, the Odysseus lander descended too quickly, hitting the ground hard. That caused one of the spacecraft's landing legs to buckle, tipping the probe over on its side and cutting the mission short. Also along for the ride, but travelling far beyond the moon, was Astroforge's 120-kilogram Odin spacecraft. It was targeting the near-Earth asteroid 2022 OB5. Odin was designed to collect imagery and other data from the space rock, paving the way for Astroforge's planned future Vestry mission, which would have landed on the asteroid's surface. Eventually, Astroforge hopes to mine 2022 OB5, as well as other asteroids, for valuable metals such as platinum. But Odin ran into trouble just hours after launch when its solar array failed to deploy properly. Astroforge says Odin's now booted into a sun-safe mode, a protective state designed to conserve power while attempting to reorient itself towards the sun. Now, if the solar panels didn't fully extend and lock, and it looks like that's what's happened, Odin would operate with severely limited power, prioritising essential systems over communication, periodically continuing to attempt to deploy its solar panels and stabilise its position. As to how long Odin can stay in this mode before losing power and tumbling out of control depends on how much power the solar panels are able to generate in this off-nominal situation. If Odin is already tumbling, mission managers say they're only expecting to receive occasional brief communications and telemetry when the antenna just happens to be aligned to the Earth. And quite frankly, that's the exact pattern they're observing in the mission at the moment. So the chances of talking with Odin appear minimal. And at this point, the accuracy of its position in space is also becoming an issue. Another spacecraft that's tagged along for the ride on the IM2 mission is the Sherpa ES Go Beyond Orbital Transfer Vehicle, a sort of space tug designed to service satellites in orbit. No word on its condition. Meanwhile, while all that's been going on, we haven't heard much about the Lunar Trailblazer mission. It was another spacecraft which was also launched aboard the IM2 mission. And it turns out NASA's lost communications with Lunar Trailblazer. It's now been revealed that communications were lost less than 12 hours after launch back on February the 26th. NASA says the spacecraft appears to have suffered intermittent power issues and mission managers don't have full telemetry from the probe or any ability to command it. Now, based on the telemetry before the loss of signal and on ground-based radar data, it appears Trailblazer is spinning out of control and in a low-power state. NASA says the condition of the spacecraft has prevented it from performing the trajectory correction maneuvers required for flybys of the Moon, which are needed to circularize its polar orbit around the Moon in order to undertake its low-altitude lunar water mapping mission. Mission managers are now looking at alternative strategies which could be used, that's if they reacquire communications and establish normal spacecraft functionality. If that happens, these may be able to place Lunar Trailblazer into a lunar orbit and allow it to complete at least some of its scientific objectives. Needless to say, we'll keep you informed. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has proven that vaping won't help you quit smoking. The findings reported in the Journal of the American Medical Association also show that e-cigarettes actually encourages smoking. Scientists reached their conclusion after analysing data from over 6,000 US smokers who took part in the Population Assessment of Tobacco and Health study, a nationally representative sample of American cigarette smokers. Now, of those, 943 smokers also vaped, and by matching and comparing these to similar smokers who didn't vape, they found that those who vaped were 5.3 and 4.1% less likely to quit smoking. The findings refute the claim that e-cigarettes can help people quit smoking, a common misperception among tobacco users and e-cigarette proponents. The authors say the science also shows e-cigarettes are not harmless, and researchers are still determining exactly what the long-term health consequences of vaping will be over the next 20 to 30 years. A new study warns that COVID-19 is likely to be more severe and deadly than either flu or RSV. The report in the Journal of the American Medical Association looked at health records of more than 141,000 United States veterans who were tested for COVID-19, flu and RSV and diagnosed with a single infection between August 2022 and March 2023, or between August 2023 and March 2024. They found those suffering from COVID-19 were linked to more severe disease outcomes, including long-term mortality, compared to either flu or RSV. The differences were more pronounced during the 2022 and 2023 season, but COVID-19 remained the most severe and deadly infection in the 2023 to 2024 tests. The World Health Organization says over 7 million people have been killed by the COVID-19 coronavirus since it was first detected among workers at China's Wuhan Institute of Virology back in September 2019. However, the Lancet Medical Journal estimates that the true death toll is likely to be above 18 million, with some 775 million confirmed cases globally. A new study claims ancient humans may have been systematically producing bone tools as early as 1.5 million years ago. The findings, reported in the journal Nature, predate the previous evidence for bone tools by more than 1 million years. The authors found 27 bone tools at a dig site in Tanzania, which were made from fragments of long bones from hippopotamus and elephants. The tools had been modified to produce a variety of sharp, heavy-duty implements that were up to 38 centimetres long. The findings suggest that early humans may have been routinely selecting specific bones from large mammals and then reshaping them using what appears to be standardised production patterns. A new podcast series looking at the pseudoscience of telepathy is proving very popular. And while that works as fiction, unfortunately, this series is betraying itself as a serious scientific journalistic investigation, which it's not. You see, it fails to provide a balanced scientific coverage of the subject. Now, for the record, there has never ever been a scientifically proven case of telepathy, even though huge financial rewards have been offered by skeptical organisations around the world, including here in Australia. However, Tim Mendham from Australian Skeptics says the show does prove one thing, and that is, we all want to believe.
Telepathy Tapes is a podcast with 7 one-hour episodes, and it's getting a lot of following. It's basically saying that people with autism, non-verbal autism, have supernatural abilities and can even visit heaven. In fact, it says that we're living in heaven, but only the people with autism of this particular sort of level can see it, and that therefore they can communicate telepathically with other people and even perform various forms of miracles. Suggestion that it's a very cruel hoax being carried out on parents who obviously are distressed about their child not being neurotypical and who are suffering from autism and the impact that will have on their lives and their families' lives as well. It's basically very similar to what's called facilitated communication, which is when people without abilities, and whether it's autism or whether it's various other conditions, mental or physical conditions, cannot sort of speak properly or communicate well, and they use a little tablet or something to spell out words, and they're often helped by someone else who's holding their arm to support them if they don't have the strength. Suggestion here has certainly been shown up by tests that the person holding the arm is the one who's actually pointing out the letters. Now, it can be because they're pointing at a screen, at a board, a bit of paper with letters written on it, and sometimes the person is not holding the hand, but they're holding the screen or they're holding the board, and they can move the board around until the person sort of presses the right letters to communicate. The tests that have been done, like, for instance, when you show the person who's not neurotypical, the person who's suffering from a particular condition, an object, and you show the facilitator a different object, and you ask the person with the issue, what did I show you? And the facilitator will then help them them out, they will write what the facilitator saw, not what the person with the condition saw. In other words, it's always the facilitator. And this is a very controversial area, and you will get rude letters from people and threats, etc., who firmly believe that this is facilitator communication is an effective tool. It's extremely, if I can say dubious, at least. And this sort of telepathy tape program endorses this system, and over a period of time it's becoming very popular, very successful podcast series. The journalist who's presenting it is talking to people who are proponents, not to skeptics. Supposedly independent journalists trying to find out, but there's a definite bias in their different inclination to believe these things. And the person they're speaking to are largely proponents, not really speaking to people who can sort of show that this doesn't work. Unfortunately, these things pop up all the time in a TV program or a podcast or whatever. We'll promote it, and often promote it effectively, and promote it to people who are desperate for some hook to hang their hopes on. And this is exactly one of those. Unfortunately, it is not a very strong hook.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.